So basically, guys, our next topic is that is called administrative distance. Administrative distance, or you can say we are writing AD. AD means administrative distance. AD is nothing. AD is just a number. AD is just a number. Getting my point? So first of all, read what I am written here. AD is a number used by router to rank the trustworthiness of the routes discovered by different routing protocol. Try to understand one thing. This is the router. Let's suppose one link is here. One link is here. How many links are there, guys, right now? Total 3 links are there.
3 links.
Agree? Now, for example, here I am running protocol RIP. Here I am running protocol OSPF, and here I am running protocol EIGRP. So on all the 3 interface, I am running the different routing protocol. Getting my point? Everyone understand? Are tell me clear now?
Yes.
For every routing protocol, again I am telling, for every routing protocol, administrative distance is already defined. This is predefined. Getting my point? This is predefined in the operating system, in the OS. Getting my point? So for RIP, what is the AD value? 120. What for OSPF? What is the AD value? 110. For EIGRP, what is the AD value? 90. EIGRP use basically 2 types of AD value, 90 and 170. Okay, na? But let's suppose 90. Now, it means all the 3 interface, there are 3 different routing protocol is running. Right, everyone? Yes or no? Yes? For example, this router receive 10.0.0.0/8. This prefix information from RIP, from OSPF, and from EIGRP. It means this router is receiving the same prefix, 10th network prefix, from RIP also, from OSPF also, and from EIGRP also. Getting my point, everyone? I hope you guys understand what I am trying to say. Clear na? This router receive this prefix information from all the routing protocol. Clear? All the 3 routing protocol. But I already told you in yesterday class, router maintain how many types of table, guys? 2 table. One is ARP table and second one is routing table. Yes or no?
Okay.
Everyone? Yes?
Yes.
Now, forget the ARP table now. Okay, na? Because ARP table, router use the ARP table only for the MAC address lookup. Okay. Now we are discussing the routing. So we are focusing on the routing table only. So come on the routing table. In routing table, router store this prefix information. I hope everyone know these things. Right now, whenever you are assigning any IP address on a router, or router learn any prefix information, router store that prefix information where? In its routing table. You know na, everyone? Tell me yes or no. Yes?
Yes.
Again telling, whenever router receive any prefix information, no matter this prefix is coming from any routing protocol, or even if you configure any static route, default route, or any routes on the router, router store all the prefix information in which table? Routing table. Clear? So it means router is receiving this prefix information from RIP, from OSPF, and from EIGRP. But router install this prefix from any one routing protocol. It means either router will choose RIP, either OSPF, or either EIGRP. But router choose only one. Getting my point, everyone? Do you guys understand what I'm trying to say? Anyone have any confusion till now? It's clear? It means
Yes.
RIP is also sending the 10th, OSPF is also sending the 10th network, and EIGRP is also sending the 10th network information. But router will choose any one routing protocol. Getting my point? Now the thing is, router will choose which network. Router will choose which network. See here, lower number indicate more trustworthy routes. It means AD value tells us about the trustworthiness. Again, I am telling what AD value is telling, guys. AD value is telling about the trustworthiness of a route. It means on a route how much you can trust. Getting my point, everyone? For example, this is me and this is Sonu, this is Monu, this is Tonu. Getting my point? So there are three people. And let's suppose if I have more trust on Tonu, so definitely I will prefer Tonu to become my friend. Yes or no? Everyone, yes? Similarly, in case of router is receiving 10th network information from RIP, OSPF and EIGRP. But router will choose only those routing protocol prefix whose AD value is less. Whose AD value is less. Because what is the rule? The rule is lower AD value always be trustworthy. Getting my point, everyone? Clear? So in this case,
Yes.
RIP has AD value 120, OSPF is 190 and EIGRP has 90. So it means this router prefer the 10th prefix. Why? EIGRP. Yes or no? Everyone, tell me. Yes? Because EIGRP AD value is less compared to RIP and OSPF. Understand, everyone? So it means when you check the routing table of EIGRP, you guys will get 10.0.0.0. Getting my point, everyone? /8, and here you guys will get the AD value, that is 90, and here you guys will get the E. E means what? EIGRP. So now you guys can easily understand this router receive the 10th prefix. Why? EIGRP. It means this router prefer what? EIGRP. Are you getting my point, everyone? Understand, yes or no? Tell me. Clear now?
Yes.
So I hope now you guys understand what is the meaning of administrative distance. So basically, please remember, always less AD value, lower AD value always be prefer, or lower AD value always be trustworthy. Clear? Understand?
Hi, Shivam. Are those
Yes.
values are fixed or like is it variable?
Yes, you can say. I told you this is already predefined. This is already predefined. So this value is, you can think this value is fixed. But yes, in some scenario, we can change it. Fine. But do not focus on these things. But right now, only focus, this is fixed and this is predefined. Clear? Understand? Now, the next one is, guys, metric. Next one is metric. See, a metric is a value used by the routing protocol to determine the best path to a destination. Different protocol use different types of metric. Now, we understand about the what? AD value, right? Lower AD value always be, guys, prefer. Are you getting my point? Yes or no? Yes?
Yes.
Are you telling me? Understand na? Now,
Yes.
see the scenario. This is the router. This is the router. This is the router. Here, on all the router, we are running, guys, OSPF. It means same routing protocol. Yes or no? Yes. So if we are running the same routing protocol,
Yes.
it means AD value here 110, 110, 110. Yes or no? Yes. For example, here I am running the 10.0.0.0/8. 10.0.0.0/8. It means this router is sending the 10th network and this router is also sending the 10th network. Now the thing is, this router will prefer which 10th network? Why R1 or why R2? Getting my point, everyone? What I'm trying to say? This router is receiving the 10th network information y R1 as well as y R2. But the thing is, this router prefer which prefix? Y R1 or y R2? Then you guys will check AD value. But what you guys will get? Sir, AD value here. On all the router, AD value is same. Then how we can decide router prefer which one? Y R1 or y R2? I hope you guys understand what I'm trying to say. What is the problem here? Clear now, everyone?
Yes.
Now, when you are getting this type of situation where AD value is tie, so after that we are checking what? Metric value. What we are checking, guys? Metric value. Getting my point? So on the basis of metric value, router decide the best path to reach the destination. It means, guys, R1 is sending the 10th network, R2 is also sending the 10th network. It means definitely here you configure the 10th network, yes or no? Then the R1 is sharing this network, yes or no? Yes. And if R2 is sharing the 10th network with this router, it means definitely you configure the 10th network here. Then R2 is sharing this network. Yes or no? Arey guys, if you do not configure the 10th network, then how R1 and R2 will share? This is not possible, na? R1 and R2
Yes.
only share the routes with this router when you configure the routes here. If you do not configure the routes, then how this router will share the routes? Getting my point, everyone? If I do not have money, then how can I give to anyone? This is possible. This is not possible. Similarly, on R1 and on R2, if you do not configure the routes, then how R1 and R2 will share the information with main router? This is not possible. Getting my point, everyone? Understand, yes or no? Let me know. Clear?
Yes.
Yes.
It means now focus here. If you guys do not understand anything, let me know, because I am explaining and I am assuming you guys don't know anything. Okay. So I am explaining from the scratch level. Okay, na? So definitely it will help you. I am just explaining. Let's suppose you can assume like ABC. This is the main router. Okay. This is the main router. This is the router number 1 and this is the router number 2. Anyone have any doubt? It's clear.
Yes.
This router is connected with any switch. This router is connected with any switch. Let's suppose there is a LAN network. Which network, guys? LAN network. And here we are using the network, for example, 10.0.0.0/8. Here I am using the same network, 10.0.0.0/8. Clear, everyone? Here we are using the which protocol, guys? OSPF. On every router, we are running the OSPF routing protocol. Now, what R1 will do? R1, when you configure the dynamic routing protocol, I am telling you one line. Please keep this mind always. Whenever you are running any dynamic routing protocol, router exchange its complete network information with each other. Again, I am telling, whenever you configure any dynamic routing protocol, router will exchange complete network information with each other, or you can say with its neighbor. Again, I am telling what I am trying to say. This is router. This is router. This is router. And this is router. Is it visible to all of you now? Are tell me.
Yes.
For example, here is one switch, here is one switch, and here is one switch. For example, here I am running the 10th network in the LAN network. Here in this LAN network, let's suppose I am running the 20 network, and here I am running the 30 network. And on all the router, let's suppose I am using the any dynamic routing protocol OSPF. It means R1, R2, and R3. R1 is connected with R2, R1 is connected with R3. R2 is connected with R1, R2 is connected with R3. It means each and every router is connected with each other. Yes or no? Yes. It means what R1 will do, R1 have information about the 30 network. Yes or no? Yes. Are tell me. R1 is connected with the 30 network. Yes or no?
Yes.
So what R1 will do? R1 will share this 30 network information with R2 as well as R3, because R2 and R3 are neighbor of R1 and you are running the dynamic routing protocol. What R3 will do? R3 have how many information? R3 have 20 network information as well as R3 receive the 30 network information also from R1. So what R3 will do? R3 will share both network information with R2 and R2 share the complete network information with R1. Now tell me one thing. When you see na, on R1, now R1 have information about 10th network, 20 network, 30 network. R2 have complete information about 10, 20, 30, 10, 20, 30. This is fine or not? Yes or no? Yes?
Yes.
It means when you configure any dynamic routing protocol, every router is sharing its complete network information with each other, or you can say with its neighbor. So that's the reason now every router know about every network. So that is the benefit of dynamic routing protocol. Clear? Everyone tell me.
Yes.
Yes?
Sir,
Yes.
let's suppose another router is connected with R3.
Another router is connected with
R3,
R3 like this.
and the information of 30th network is also shared with the R4.
Who is the neighbor of R3 is the neighbor of R4? R3 has all the information about 10, 20, 30. Yes or no? Yes?
Yes.
R3 will share the complete network information with R4. But next sure you are running the same routing protocol here.
Okay. So if I use the REAP protocol,
Any
then it will
routing
not work.
protocol, OSPF, EIGRP. But let's suppose here you are using the OSPF and here you are using the EIGRP or RIP. You are telling this one, right?
Yes.
So this will be the different scenario here. If you want to make communication possible in the different routing protocol, in this case, we need to perform the one method or one process that is called redistribution. What is redistribution? Getting my point, everyone? But in one routing protocol, every router exchange the complete network information with each other. Clear? Understand?
Yes.
Tell me. Okay. So see, this is the 10th and here the 10th. What this router will do? Here we are running the OSPF. So this router share the complete network information with this router, and this router share the complete network information with this router. R1 will share which network information, guys? 10th, because R1 is connected with the 10th network. Right now, everyone? Yes or no? Yes? And R2 is also sharing the same network. Now, this router receive 1/10th network information on this interface and same 10th network information on this interface. First of all, this router will check what is the AD value for both network. Then this router will find for both network AD value is 110 because I am receiving the both prefix from OSPF. Yes or no? Everyone, tell me. Yes, na?
Yes.
For example, if here you are running the OSPF and if here you are running the EIGRP. So in this case, router will prefer YR2. Why? Because its AD value is 90. Yes, na everyone? Yes or no? Yes. But in this scenario, what is happening? In this scenario, on all the router, you are running the same routing protocol, OSPF. So this router is receiving the same prefix, YR1 and YR2. First of all, router will check the AD value, but for both prefix, AD value is tie. After that, router will choose the, check the metric. What guys? Metric. Getting my point? And on the basis of metric value, router will decide either I need to install 10th network by R1 or R2. Getting my point, everyone? Do you guys understand? Clear? I hope you guys
Yes.
understand what is the meaning of metric. Basically, on the when AD value will tie, then the next scenario is metric. Router will choose the best path according to the metric. For example, and one more thing, please see here. I think I already written the lower metric is always preferable. Router always prefer lower metric. Getting my point? For example, this router is sending the 10th network information with this router and metric is 32,000. And this router is sharing and metric is 40,000. Now tell me, this router will prefer by R1 or by R2? Which one? This main router will prefer the 10th network by R1 or by R2? Answer is
R1.
by R1. Why? Because by R1, this router is receiving the metric value. How much? 32,000. But by R2, this router is receiving the metric value. How much? 40,000. And according to the rule, lower metric always be prefer. So this router will prefer 10th network information by R1. Getting my point? And this router install in routing table like 10.0.0.0 by R1. It means if there is a switch, there is any end user, and this user ping 10.0.0.1, packet will come on the router, and router forward this packet towards here. This router forward this packet towards R1 because this router install the 10th network information by R1. Yes or no? Everyone tell me. Understand?
Who
Yes.
will provide that metric value? Shubham?
Sorry?
Who will provide that metric value and how it will find that who is having less value, metric value?
Less metric. You are telling metric, right? See, basically router calculate the metric value for, see, this is not fixed first of all. Every routing protocol calculation of metric is, you can say, method is very different. For example, RIP. And please remember, RIP nowadays we are not using, completely not using. Clear? Now come on the OSPF and EIGRP. OSPF use the metric calculation that is called cost. What is, guys? Cost. Getting my point? OSPF use which method? That is called cost. Getting my point? And basically OSPF calculate the metric on the basis of bandwidth of the link. What is bandwidth of the link? Are you getting my point? For example, here you are using the fast Ethernet link and here you are using the Ethernet link. So for fast Ethernet link, what is the bandwidth? 100 Mbps. And for Ethernet link, what is the bandwidth? 10 Mbps. Yes or no? Yes? Getting
Yes.
my point? So on the
Yeah.
basis of bandwidth, OSPF calculate the metric value. Fine. But how? We will discuss these things in the OSPF. I will tell you, basically OSPF use one formula. Okay. And on the basis of that formula, OSPF calculate the metric. Clear? But right now, just understand, on the basis of metric, router will choose the best path. First line, second line, always lower metric will be preferable. It means router always prefer lower metric value. Clear? Point number 3, every routing protocol, the calculation of metric is different. For example, OSPF use the cost and EIGRP use the different method. That is called K value. Okay, we will discuss these things later. Getting my point? So please remember this one. Different routing protocol have different metric calculation method. Clear now? Anyone? Any doubt? Are tell me? Clear?
Yes.
Yes.
So that is all about, guys, metric. Now the next one is gateway. Gateway of last resort is the route used when no specific route to a destination exit in the routing table. It is like a default route that tells the router if you don't know where to send the packet, send it here. Guys, gateway of last resort, or either you can say the default route. That is called default route. Please think like this.
Shubham, are you speaking?
Sorry?
Sorry, my earphone was unplugged. Sorry.
Anyone have any doubt? This is clear now? What I configure here? Everyone. I hope this is clear to all of you. Okay. I have 3 router, 3 switch, PC. So here I am using the which network, guys? 10th network. Here 20, here 30, between this router 50 and between this router 40. This is clear now, everyone? Are yes or no? Yes?
Yes.
Yes.
For example, here I am using the IP address 10.1, 10.2. Sorry. Let's suppose here I am configuring 10.1. Here I configure 10.10. Here I configure 20.1. Here I configure 30.1. 20.10. 30.10. 40.1. 40.2. 50.1. I hope this is clear to all of you how I can configure the IP address. Clear na, everyone? Now we
Yes,
are
sir,
discussing,
clear.
guys, gateway of last resort. Okay, but don't remember this keyword. Understand default gateway. Sorry, default route. There is a difference, guys, between the default route and default gateway. Default gateway, I think in study class I have already explained you, right now? Are you tell me?
Yes.
Yes, sir.
Okay.
Zip code of the network.
So default route means, understand. For example, from PC number 1, you ping to PC number 2. From PC number 1, you are pinging from PC number 1 to PC number 2. Packet initiate here. What is the source IP address, guys? 10.1, and destination IP address will be 20.1. Yes or no? Everyone, tell me.
Yes.
Yes. Tell me. Yes. Packet will reach on router. Yes or no? Yes. What router will
Yes.
do? Router check its which table? Routing table. Are which table? Routing table. But in the routing table of R1, what are the information you guys will get? 10th network, 40 network. Yes or no? Yes, na? Because with
Yes.
R1, How many networks are right now directly connected? 10th and
2.
40. It means C means directly connected. It means 10th network is connected with, let's suppose, fast Ethernet 0 by 0, and this is 0 by 1, and 40 network is connected with the 0 by 1. Is it fine or not? Yes? Or tell me.
Yes.
Now what router will do? Router check what is the destination IP address. Destination IP address is 20.1. It means this belongs to which network? 20 network. Router will try to find out 20 network is present in my routing table or not, because router always take the forwarding decision on the basis of routing table. Clear na? So router check 20 network is present in my routing table or not. Then router will find, no, in my routing table only 10th network and 40 network is there. 20 network is not there. Yes or no? Yes? What R1 will do? R1 will drop
the
this packet here. Because R1 do not have destination route. R1 don't know where I need to forward it. Are you getting my point? Yes or no? Yes, na?
Yes. Yes. Yes.
Yes.
That's the reason R1 will drop it. Clear? Understand? Now, what you will do, you can configure one command on R1. You can configure, please see very carefully, IP root 0.0.0.0 0.0.0.0 40.0.0.2, or either you can write this interface. What is the meaning of this? Try to focus here. IP root, this is the command. Here, I write here 0.0.0.0.0. It means, what is the meaning of this? It means any
Source.
IP. Any IP, or you can say any source. Any source IP. Clear? What is this? With any subnet mask. With any subnet mask. What is this? This is called, tell me, this is called next hop.
Next hop IP.
Either this is the next hop. If you write 40.0.0.2, it means this is called next hop IP. And if you are writing this one, and this is called exit
Outgoing
interface.
interface.
Exit interface. Now, I write this command and I hope you guys understand it very carefully. When I write this command on R1, it means you are telling to R1, कि, hey bro, when you receive any prefix with any source, no matter it is coming from 10, 20, 30, 40, any source, with any subnet mask, what you have to do? You have to forward that packet either towards this interface. If you write this one, then this router will forward every packet towards here. And if you are writing this one, it means this router will forward each and every packet through fast Ethernet 0 by 1. This is called default routing. Anyone who do not understand? Clear? Are tell me.
Yes.
Understand? Anyone? For example, on R3, what you guys will configure? IP root with any source IP, with any subnet mask. What R3 will do? Either R3 needs to forward this packet towards 50.1, or either with interface, let's suppose 0 by 1. Yes or no? Everyone, tell me. Yes, na? That is called default gateway. So basically, what is the use of default gateway? If router don't know where I need to forward the packet, you can configure the default route, and on the basis of default route, router will take the forwarding decision. Understand, everyone? Clear na? Anyone who do not understand? So that is called default routing. Now, guys, anyone who do not understand, please let me know. Then I will clear you. Otherwise, I am erasing it.
So is default route is possible based on destination IP also?
Destination IP, yes, why not? Okay, I hope this is clear to all of you about the default gateway. Sorry, default route. Are they clear now, everyone? Yes or no?
Yes, sir.
Yes.
Now the next thing is, how does the router take the forwarding decision? This is the basic question, or maybe many interviewer will ask you this question. How router will take the forwarding decision? Let's suppose if router receive any packet, how router will take the forwarding decision? So there are steps. Router will follow mainly 3 steps, guys. In step number 1, router check the longest prefix match. In step number 1, router check the what? Longest prefix match. What is longest prefix match? The longest prefix match rule is the first thing router look at when deciding where to forward the packet. It determines which route in the routing table has most specific match for the destination IP address. For everyone, please focus on the example. When you focus on the example, it will clear. For example, you want to send a packet to this IP. This is the IP address. So it means this is the destination IP address. Yes or no? Everyone. Yes? Are tell me.
Yes.
Are do you guys
Yes.
understand? Yes,
Yes.
or no?
Yes.
What I am trying to say, for example, this is the router. This router has one routing table. This router has one routing table. In this routing table, this router maintains 2 routes in the routing table. For example, 192.168.1.0/24. 192.168.1.0/26. 2 routes are there. You are sending any packet. What is the destination IP address in your packet? 192.168.1.50. This is the destination IP address you are sending. What this router will receive this packet? Yes or no? Yes. What this router will do? This router check the routing table. Are this router check the what? Routing table. Are tell me yes or no? Yes, na?
Yes.
When this router check the routing table, this router will check among these 2 prefix, because these 2 prefix match this one, because this one 192.168.1.50, this is the IP address, and these are the network. So this IP address belongs to this network as well as this network, both. Yes or no? Yes, na?
Yes.
This IP address belongs to this network also as well as this network also. But router will choose any one. Are you getting my point? Yes or no? Router will choose any one. But the thing is, which one? Now router will check 192.168.1.0. What is the subnet mask here? /24. And what is the CIDR value here, guys? /26. It means /24 means what? 24 means what? Who can tell me? If I am writing the /24, in yesterday class I told you. What do you mean by it?
24 network bit.
Yes, 24 bit is network bit. And if I am writing the 26 bit, it means 26 bit is network bit. It means what you can understand, 24 bit is matching here, and here 26 bit is matching. So what router will prefer? Router will prefer the 26 bit matching. Why? Because this is more exact compared to this one. Yes or no? Everyone, tell me. Yes, na? Guys,
Yes.
yes. In this route, there is only /24. It means only 24 bit is matching. And here 26 means 26 bit is matching. So which is more preferable? 26 is more preferable, or you can say on 26 you can trust more. Are you getting my point? Yes or no? Yes, na?
Yes.
Because in 26 maximum number of bits are matching, but on 24 only 24 bits are matching. So you will prefer 26. So that's the reason router will prefer only always 26, and that is called longest prefix match. So whenever any routes will reach on the router, the first thing router will check, that is called longest prefix match. What is, guys? Longest prefix match. And on the basis of longest prefix match, router will take the forwarding decision. Clear? Understand? Everyone. Now,
Yes.
let's suppose longest prefix match is tie. For example, this router has only this one. Only this routes are there. It means now you cannot compare. Now you cannot compare. Yes or no? Yes, nah. Everyone. In maximum case, you guys will get longest prefix match is tie. Getting my point? Generally, router in real scenario also, generally router is not taking the forwarding decision on the basis of longest prefix match. Okay, because these are always, what I can say, these are always tie. Okay, na? So what is the second condition? Second condition is AD value. So when longest prefix match will tie, router will check the AD value, guys. I hope AD value I already explained you. Right, na? Which AD value always prefer? Router will always prefer less or high.
Directly connected.
Lower
less
AD
AD
value
value.
always prefer. Clear, na? For example, if you are running the OSPF, it means what is the AD value for OSPF routes? 110. 110.
Zero.
If your router receive the routes from the EIGRP, then what are the AD value for those routes? 90.
90.
For RIP routes, 1 to 0. And for example, on this router, you configure 192.168.1.1. It means this IP address belongs to which network? 192.168.1.0. Right? So for this network, what is the AD value? 0. Because this is directly connected. Yes or no, everyone? So please remember, for directly connected routes, AD value is always 0. Are tell me yes or no? Yes, na? Are tell
Yes.
me.
Yes.
Yes, na? For example, let's suppose you are telling me something, and if I'm and same thing, I am seeing the live. So on which you guys have more trust? What you are seeing live? Yes or no? Are tell me yes, na? So definitely, let's suppose this router receive any routes from any routing protocol, or if that the same route is directly connected, definitely router will trust on directly connected network. Yes or no? Yes. So that's the reason for directly connected network, AD value is always 0. Because this is the most trusted network. Because these networks are directly connected. Are clear, everyone? Yes or no? Yes, na?
Yes,
For
sir.
example, I told you about the static routes. For example, if, static routes means you are telling router where you need to forward the packet, right? Manually. That is called static route. In the study class, I told you. For static routes, AD value is how much? 1. For AD value, what is the static value? Are tell me.
1.
For AD value, what is the
1.
static value?
1.
1.
Understand, everyone? I hope you guys understand. Clear?
Yes.
So that is called the second condition router will check, guys, AD value. Clear, na? So first parameter, what router will check for the forwarding decision, that is called longest prefix match. When longest prefix match will tie, router will prefer what? AD value, lower AD value. Clear, na, everyone? But any scenario, AD value is also tie. I already told you, na. For example, on all the router, you are running the same routing protocol. It means your router is getting the routes from OSPF. It means for every routes, AD value is 110. Yes or no? This is the router. Let's suppose here is one more router, here is one more router, here is one more router. And on all the router, you are running the OSPF. On all the router, you are running the OSPF. It means this router is sending any route, this router is sending any routes, or this router is sending any routes. For every routes, AD value is 110. It means AD value is also tie. Are yes or no, everyone? AD value is also. So in this case, after that, what router will check? Router will check metric. What guys? Metric. So it means on the basis of metric, now router will prefer the best path, or router will choose the best path. Are clear na everyone? Yes or no? Understand?
Yes.
So if anyone asks you in an interview, tell me how router will take the forwarding decision, what you can say? Whenever router will receive any routes, router first of all check the longest prefix match. When longest prefix match will tie, then router will check the second condition, that is called AD value. And lower AD value always be preferable. And if AD value is also tie, then router will check the what? Metric value. What guys? Metric value. Are you getting my point? Yes or no? Yes, na?
Yes.
Metric value. And on the basis of metric, router will choose the best path, and lower metric always be prefer. Lower metric always be prefer. But if I will be your interviewer, I will ask one question. Can I ask you? Are you guys ready?
Yes.
Please.
I will ask the simple question. Tell me, this is my router. This is my R1 router. This is my R2 router. Link is connected like this. Here I am using the fast Ethernet link. Here I am using the fast Ethernet link. Here is, let's suppose, 10th network. Here is also, let's suppose, 10th network. On all the router, we are running the OSPF. Now tell me, this router will prefer 10th network, why R1 or why R2? What will be your answer? First of all, girls, anyone from girls side who can tell me the answer? Pravavati, Simran, anyone? No one? Then, boys, who can answer?
So AD and metric are same. No.
Guys, when R1 will send or R2 will send, this router check first of all longest prefix match, right? According to the rule, right? Na? So longest prefix match is tie. Clear na? Longest prefix match is tie. Second one is AD value. AD value is
AD
one
value.
because on all the router we are running the OSPF. Third one is guys metric. How
Metric.
OSPF calculate the metric on the basis of bandwidth? You know na everyone? Yes.
Bandwidth.
Yes.
Yes.
Here I am using the fast Ethernet link. What is the bandwidth? 100 Mbps.
100
And here I am
Mbps.
using the fast Ethernet link. Bandwidth is 100 Mbps. Right? It means for this link and for this link, metric is
Accept anyone.
same. It means bandwidth is
On the
also
side.
tie. Are you tell me yes or no? Right now, metric is also tie. So if metric is also tie, then this router will perform the load balancing.
Mhm.
What is load balancing? What do you mean by load balancing? Load balancing means this router install both routes by R1 as well as by R2 in its routing table. Clear everyone? Understand? That is called load balancing. What is load balancing? How load balancing will work? We will discuss these things later in the dynamic routing protocol. But right now, I'm just telling you, when all the three parameters will tie, then router will perform the load balancing. Getting my point, everyone? Understand? And load balancing means this router, main router will install both prefix in its routing table. So whenever this router will receive destination IP address, this 10th network, what this router will do? This router will forward, let's suppose, some packets through this link and some packets through this link. Are you getting my point? Yes or no? Yes.
Yes.
So in this case, what will happen? The load on the single link will be minimized. Otherwise, let's suppose this router choose only this one. It means if there are 1,000 number of packet, so this router is sending only through this link. It means load on this link is quite high, na? Yes or no? Yes. So minimize the utilization. What we can do? We can perform the load balancing. Are you clear? Understand?
Yes.
So we discuss how we perform how router will choose the best path. I hope this is clear to all of you, everyone.
Yes.
Okay. So the next thing is, guys, about configure the static routes. Okay. But I am thinking today is not the best time to discuss how to configure the static routing. Okay. In tomorrow class, I will show you how to configure the static routing practically. Clear, everyone?